Hello everyone, my name is Daniel Bartlett, and in this video we'll be looking at the brand new Volumetric Lattice tool that came to Fusion 360 in the January release. I'm really excited to share this technology with you. It's brand new to Fusion 360 and I can't wait to see how Fusion users can utilize it. To access the tool, there are two quick things you need to do. Firstly, you'll need to purchase the product design extension, which can be done by clicking the extensions button in the toolbar and selecting product design. If it's your first time using the extension and just want to try out the tool, you could try the 7-day free trial. Secondly, as this tool is still a preview feature, you'll need to go to your preferences, click preview features in the menu and enable the Volumetric Lattice feature flag. You should now see the tool in your design workspace under the Modify tab. For this demonstration, I'll be creating a heatsink for a circuit board, which we will then additively manufacture. A heatsink is a part that can be used to dissipate heat, usually from electronic components. Before we begin, we need a part that we'd like to lattice, and here you can see the geometry of a heatsink that I created earlier. So I'll click on the Modify tab and select Volumetric Lattice from the list. To start with, we need to select a part that we'd like to lattice, like so. This can be a solid body or a mesh body. As you can see, we immediately visualize the lattice throughout the volume. With a traditional approach to creating lattice structures, you have to select all of your settings beforehand and then generate the lattice. This is because of the computational complexity of creating lattice structures in this way. The benefit of a volumetric approach to lattice generation is that we can see the lattice appear in real time and see how changing certain variables will impact the structure. Next, we can select the cell shape for our lattice structure, and we currently have 3 to choose from: the gyroid, which you can see at the moment, the cross cell shape, and the Schwartz P cell shape. For this demonstration, we'll stick to gyroid. We can scale the structure by selecting this option and dragging the in-scene manipulator. We can scale both uniformly and non-uniformly. We can also move the structure throughout the body by using the Move and Rotate command. And this can be really useful for aligning lattice structures with the surface of parts. In the next tab, we have control over the solidity of the lattice structure. We have 2 options for controlling the distribution of solidity through the lattice structure, either uniformly or by creating a gradient along a path. With the uniform option, we can vary the solidity using this slider, or we can manually input a value between 0 and 100 in this box here. In my opinion, the more interesting option is to use the gradient along path option. With this tool, we can select a path, which can be a sketch line, an edge of a body, even a complex spline line will work. For our demonstration, we'll select this line here. And we can see that we now have a gradient going through the part. At one end of the line, we have the density of 0, and at the other of 100. This can be extremely valuable for creating complex lattice structures with variable physical properties. We have control over density at the start and end points of the gradient, and we can vary that with this slider here. We can even change the position of these points along the path. In the final tab, we're able to modify our lattice structure using an offset region. We can add a region by pressing the plus icon. And we can then select a face, an edge, a sketch object, or a completely separate body to be our object. In this case, we'll select the bottom face of the heatsink. We have the option to add as many objects as we need. By selecting an object, we've now created an offset region. We have complete control of the thickness of that offset region, and we can control the solidity in this region. We also have the option to vary the blending distance, which creates a gradient between the solidity of the lattice in the offset region and the solidity of the rest of the structure. We can also add more offset regions by selecting the plus icon again and selecting another object. These extra regions have their own thickness, solidity, and blend distance, and if we decide we no longer want the offset region, we can delete it using the cross icon, like so. Once we're happy with the structure that we've created, we can just click OK. Now we've designed our heatsink, we need to manufacture it. To do this, we need to convert our body, which has volumetric information, into a mesh. Certain 3D printer manufacturers require mesh as an input, whereas others accept toolpath data from print preparation software. In this first release, we focused on the mesh conversion workflow, as it ensures compatibility with the largest number of machines, processes, and existing workflows. But in future releases, we will explore workflows that do not require this mesh conversion, and we aim to create slices and toolpaths natively in Fusion 360 for models containing volumetric lattice information. But for now, we need to create a mesh. To do this, we can find our body and right-click on it. In this menu, we can find all of the tools that we have to interact with the lattice. We can select the Edit Volumetric Lattice option in the list to make changes to our lattice structure if we need to. We can also go into the Volumetric Lattice Actions submenu, and in here we have a couple more options. We can show or hide the lattice structure, we can create a mesh from the volumetric information, or we can delete the volumetric lattice. I'm going to select the Create Mesh option. We have a few refinement options. For now I'll just stick to medium and I'll press OK. With our mesh generated, we can make any changes we like using the tools in the mesh workspace. Or, if we're happy with the final design, we can take it into the manufacturing workspace. To produce this part, I'll create an additive setup, and I'll select a one-click metal machine. From here, we can quickly create some supports, generate the toolpath, and export it to our machine. So this has been a very quick introduction to the new volumetric latticing tool in Fusion 360. I hope you have found this video interesting, and I'm excited to see how this tool is used by the community. Thank you very much for watching, and if you have any questions, please just reach out.